Well, welcome to, oops, to the, did you see that? Yes. Welcome to Comp 620, Information Privacy and Security. Everybody get a chance to see this? Everybody get a chance to see the cartoon? Oh, it's important. Okay. All right. Moving on. A couple of announcements. This is just a regular public announcement that elections are coming up in November, less than a month away. If you are not registered to vote, or if you want to change your party affiliation or something like that, you need to do so by this Friday. We have 2 days, 5 o'clock on Friday the 14th. You can register when you do early voting. Early voting here in Guilford County is from October 20th to November 5th. And when you go to early voting, if you are not registered, you may register then. The election day is Tuesday, November 8th. You may not register on election day. So if you're not registered after November 5th, then you're not voting. You might note, here's the schedule coming up. I didn't go any farther than this, but sometime before the election, we do have a lecture on voting security. And I have, in my spare time, when I'm not torturing students' minds, I am the chief judge of our precinct. So I'm aware of what they do with the voting systems. There is an assignment out there. It's for everybody, graduates and undergraduates. I waited until the due date of the research paper to put it out there, not to scare the graduate students. You have to go to the website and answer. There are 4 questions loaded on Blackboard, and they all involve using the website. What you'll note is a non-campus website because the on-campus people did not make it easy to have a website. So I went someplace else. They're probably happy about that. It's due at noon next week, noon, not before midnight, but noon. That's because I want to be able to grade it and give you and have you see the results of the grading before the exam, which is a week from today. So if I didn't have it, but wait too long. I know we want more time to do it, but I want to be able to grade it. Although I don't know why I give you more time. I'll tell you. Nobody does it the night before. I don't know why I make deadlines anything more than tomorrow. So, yeah, so there it is. And answer people's questions. People already told me, well, they can't log in. Well, because they've got their user ID, which is the last 3 digits of your banner ID, your one ID number. Password, I'm not telling you the password. You're going to have to log in without a password. That's the challenge. Okay, last lecture, people were unsure about what base 64 encoding is, so let me just spend a couple minutes describing base 64 encoding. The whole purpose of this is to be able to transmit weird and unusual characters across the web without causing difficulties on systems that are used to transmitting characters. There's a lot of strange characters out there besides the letters and numbers. There's the control characters like NAC and ETX and character return line feed along. Well, there's 8-bit bytes, so there's 2 to 8 is 256 possible values. There's only 92 keys in the keyboard, so there must be a bunch of characters that are not on the keyboard that you can transmit. So yes, and they can cause difficulties. So base 64 encoding converts any bunch of bits into letters and numbers. So you can transmit across systems that use letters and numbers without causing any difficulty, and then convert them back to the binary values. It's real simple. It takes 3 8-bit bytes. 3 times 8 is 24 bits, and divides it into 4 6-bit values. 6 times 4 is also 24 bits. And then the 64 values that they use are letters. They have the 26 uppercase, 26 lowercase. That's 52, add the 10 numerical digits, that's 62, plus and a slash, and you're up to 64 values. So, but using letters, numbers, plus and slash, you've got enough numbers and letters. If you transmit just those, you can then convert it back. Now, it does get a little challenging when the number of input bits is not evenly divisible by 6, because it does convert 8-bit bytes to 6-bit values. So they use equal signs to pad it. You can see how they pad it out with equal signs. So often you may see an equals or 2 equal signs at the end of base 64 encoding. There are several websites out there that will base 64 encode or decode for you. Just go to the website, copy and paste what you want, and you can get it decoded for you. Here's an example. I took the name of the course and then encoded it. Now, it was actually kind of silly to encode the name of the course because it's all letters and numbers, except for the ampersand there. Everything else is letters and numbers. There's a slash there, but of course, slashes are legitimate characters. But you can see it's converted to something that doesn't look like it is not encrypted because there's no key. Anybody who has that can decrypt it or decode it back to what it was. Also note, because it takes 3 8-bit values and converts it to 4 characters, that it is 4/3 longer than it originally was. So you have to account for it being longer. So typically, whenever you see something out there, it's a mixture of letters and numbers, particularly if it ends with a couple equal signs, that's base 64 encoding. Might point out that if it only ends, if you see a value as only letters and numbers, and the only letters in A through F, then it may be a hexadecimal value. But otherwise, if you see letters and numbers like this, it's base 64 encoding. There are other encoding systems, but base 64 is the most popular. Cookies. Now, people told me they understood cookies last time, but I just wanted to go over cookies briefly to make sure everybody understands cookies enough to answer the questions that are going to come up about cookies. Okay, a cookie is a little piece of information that is sent along with a web page from the server, and then the browser sends it back to the server. This information is not displayed. It's kept hidden from the user in a sense, and it allows to identify users. Here's the basic concept. Start with a web browser. You want to go to a web page. So you say, type in user subject, sends a request for the web page. The server sends the web page back. That's this hello world, along with the cookie. The cookie is also sent back as part of the HTTP headers. It's basically an option in the HTTP headers. It's sent back. And then your browser saves that cookie. Then when you request another page from that same server, it sends the cookie along. So the server can get that cookie. The big reason is that the web servers don't keep any state. That is, they don't remember who's logged in or using the system. They often have a database of users and stuff, but it's what they call stateless. They don't keep track of people being logged in, except when you log in, they might put a cookie out on your browser, and when your browser sends the same cookie back, they look at that cookie and they say, oh, this is a cookie from a logged in user. I know who this is. And usually it has a session ID for HTTP session. And then it can use that session to find out what streamers, and therefore, in a sense, provide a series of states or continuing connection to that user. So web servers, REST API servers, a REST API server, it's basically a website that is not intended for human beings. Most websites produce, well, not most, a lot of websites produce web pages that humans are expected to look at. There are a whole bunch of web-based servers out there that do not show you pages. Instead, you send a request to them using the normal HTTP format where you have the website / and a question mark, parameter equals a value, ampersand, parameter value, and so forth. And what it is a function call or a method out there on this website. You call the particular function on that website, passing it the parameters, and then it does whatever it's supposed to do and sends back a file, usually an XML file or maybe a JSON file. And so the program that made the request to that server gets the information back. There's all sorts of them out there to do all sorts of things. I've used one in class before that gets the weather. The government weather people, NOAA has an API system. You can send it a request and it sends you an XML file with the weather predictions. So you can have your own weather app. So the cookies are there to allow you to keep track of a user. In particular, if you log in, a lot of servers require you to log in first. How do they know you're logged in? Because it's stateless. They put some information in the cookie, and then if you present that cookie when you back again, it says, "Oh, I know who this user is. This is an authorized user, and we'll let them access this information." What goes in a cookie? Anything the server wants to put in a cookie. Frequently username, so it can come back and say, "Hello, Fred, this is you." Keeps track of what you visited, all sorts of form data, whatever you want. There are two flavors of cookies. There are session cookies and persistent cookies. A session cookie is temporary. A session cookie lasts only for the session, only for that connection. You go to a website, it sends you a cookie, and then if you ask for another page, you send the cookie back and forth until you're done. As soon as you close your browser, the cookie is deleted. You can often tell a session cookie when you look at it because there's no expiration date. And of course, that's slightly safer because there's nothing stored in the browser about that. Persistent cookies are saved when you go out to the website and the server sends your cookie. Excuse me, try again. When the server sends your browser a cookie, that cookie is stored on the local disks of your browser, and it keeps it and will use it the next time you connect to that system. These sort of cookies will have an expiration date or a max age. If you look down here at this example, you can see that there's an expires date, there's a max age that somebody said it's good for that long, it's good for this, and that cookie can only be used during that time period, but it will keep that cookie for that length of time. And so this is longer than a day, if you go to that website, you come back tomorrow, it will know the information that's stored in the cookie. Amazon does that. I know when I go back to Amazon, it just goes, "Oh, hello, Ken," and lets me keep on buying things. Oh, so we have our first clicker question for today. So if you are online, I am launching the question. If you're here in class, get your clicker cards out. Anybody need a card? Yes, okay. Okay, a couple cards. Please give them. Okay. That's 80% of the online people have already responded. Okay, theory class, let's get your cards up so we can see who you are. Okay. Well, I didn't fool too many of you. Yes, most of you voted to base 64 decoded. That is, of course, correct. You can. Yes, it can't be a hexadecimal because there's characters here other than numbers and A through F. AES decrypted. Well, it'd be hard to do if you didn't know the key. Now, if it's in a cookie, now could be encoded, but your browser doesn't decrypt these things. So it's most likely in base 64, which in fact, that's a tasty cookie. There are options for cookies. I think if you go back here and look at this, you can see several cookie options besides the fact that it's got the expires, the max age. This is HTTP only, secure, path. These are cookie options. Secure means this cookie can only be used over HTTPS. You will not send the cookie on an HTTP not encrypted connection. HTTP only means that this cookie cannot be accessed through JavaScript or from the HTML, only to be used for sending it back and forth. Path tells you where to store it. Each site stores the cookies separately. In other words, the cookies from acme.com are not stored with facebook.com. They're kept separate. But within that one site, you can create directories and where you want to put the cookies. You can specify a path. Domain says that this cookie not only works in this one particular site, but any subdomains of this site. So if it's www.acme.com, it can also be whatever.acme.com and something.acme.com. So if you go to the whatever website, since it's part of the acme.com, it will work there too. Now there's also a same site cookie. It says that only, actually 3 values. If it's strict, you can only use this cookie on the site that gave it. Otherwise, you might be able to send it to other sites. There are third-party cookies. Third-party cookies are sent to other sites. But the first-party cookie comes from where you go. So if you go to acme.com and acme.com sends you a cookie, a first-party cookie is from acme.com. But on the web page that they send you, there may be usually advertisements. And so you go and make a request, because remember, all files on the web page are accessed independently. If there's pictures or advertisement text, it goes out to that advertiser's website and retrieves the page and displays it. As it goes to that website, it may send cookies for that website. Again, in my example, if you go to Acme and you have ad guy things, it will go out to someplace, and it might go to some other website. Ad guy keeps track of what you accessed, those other things. Here's an example. This website, I took this from my wife's computer, because I don't touch this stuff. You can see all sorts of things. If you click on any one of those, it will send the cookie to that company. Cool. My wife and I used to share Amazon account. I buy something, she buys something, money comes from the same place anyway. So what difference does it make? Well, it makes a difference because coming around Christmas, I was out on Amazon looking at something. I was going to buy her a widget. Then, after, almost immediately after that, anytime you go to a website, you start seeing advertisements for widgets on the side. So would my wife. So that wasn't any good. She'd know I was thinking about widgets. I wanted to surprise her. So we've now got separate accounts on Amazon. So I can look at something on Amazon and she doesn't have to know about it because, again, third-party cookies, yes, you see them all the time. Amazon and Google all cooperate together so closely. You go to a website and you know what you've looked at on Amazon. You can figure it out. Yes, there are tracking cookies. They keep track of your browsing habits. In other words, these cookies are sent to the company and they go, oh, you clicked on this, you're interested in this particular topic at this time. And so they keep track of where you're looking at, what main page does this come from? Because in part of the HTTP request, it says, well, where did you get this link? Did it come from another page? Was it a link in another website? If it was, it tells you what website it was. So now they know what website you're looking at, what sort of stuff you're interested in. They keep track of all sorts of stuff. What time you visit the website. Now, the cookies have valid purpose for session management to keep track of who's logged in, who you are, what you're doing. It makes the stateless servers somewhat stateful so that they know how to run a series of web pages, that you are following the appropriate series and you didn't just jump into the middle. Cookies also personalize it when you come to a web page and it says, "Hello, Fred." It knows who you are from the cookie that is stored there earlier. That would be a persistent cookie. Its name earlier, now it knows who you are, along with all sorts of other information. Here's a cookie I got from the North Carolina Digital Library. By the way, if you read Kindle or other ebooks, instead of buying all the books, you can get it, check them out from the North Carolina Library. They're free. I like the price. And this is a rather large cookie that it sends with all the information I was interested. Here's an old email address I don't use much. What really interested me is the checkout limits by media type. There's ebook 6. And I always thought, well, what if I edited this cookie before I let it go back? Could I check out more? I have a hard enough time reading 6 books within that 14-day time period anyway. You guys keep me busy. So, yeah, so that's a cookie, and all sorts of information stored in there. You can look at the cookies. There's a program, curl, that's a CURL, command line URL, I think is what it stands for. It's a command line function on Windows. If you go to the command line, the black screen where you type command line functions, you can type curl space HTTP : / and it will just like a web browser, it shows you what it gets. If you use, I think it's the I option, -I, it will show the headers. So you can see everything that goes back. It runs on Macs also. If you're in the browser, you go to debug mode and you can put a watch on cookie.com. And if you just mouse over it, it'll show you the whole cookie. Yes, there are multiple browsers and types, and several of them have debugger modes. I know Chrome does, Edge does, Safari does, Firefox. Firefox has one of the better debuggers, in fact. Yes, Firefox. Anyway, I tend to use Chrome. Control-Shift-I will get you into the Chrome debugger. Click on the web page that you're looking at. It will show it to you. If you get an error, it'll down the console bottom, it'll tell you what the error was, because there are a lot of errors that don't print any messages. Sometimes they go to a web page, particularly when I'm experimenting, perhaps making assignments for students, and I click on it and just staring at a white page. What's it doing? You can go into the debugger, look at the console, and see the error message in detail, and tells you what line, why it is not working, which really helps you a lot. A lot easier to know what's going wrong when you get an error message than if you're just looking at a blank screen. Now, cookies do have some issues. Cookies keep track of you. And so in some sense, it's keeping track of your information. Big Brother is not necessarily watching. All of his cousins are watching. It seems to me that private industry follows you much more than I believe the government does. Well, it now comes to the point where if suddenly the FBI becomes interested in you, do they start looking into the first thing the FBI does is they go out to one of these websites and they purchase your information from them because they already have all sorts of information on you. Why should they start from scratch? Now, again, cookies identify you. If you go to a different computer or use a different browser, if you're using Chrome and then you use Microsoft Edge or you use Safari, that browser won't have your cookies, and so the website won't know who you are. Also, sometimes when you did an update, because The cookie gets updated because you went someplace, then you go to the back button, the page you're looking at, and the cookies make it out of sync. That happens. Now, the European Union has some concern about cookies because they do track you. And the European Union has stricter privacy rules than you'll generally find in the United States. So natural persons, that's humans, can be associated with cookies. And therefore, since they're keeping data, they're subject to the general data protection regulations of the European Union. In the last few years, if you go to websites, you'll often see a banner at the bottom of the page saying, this site uses cookies. Please click here to accept using the cookies. Or if you go any other page, we assume that you've accepted it. Some of them have a nice option that tells you, we'll go up here and set your preferences for cookies. And you can specify of the half dozen different types of cookies they use, which ones you accept and which ones you don't want to accept. The reason you see these now is because the European Union requires them. Most websites don't worry about where you're going and try to change the website if you go into the European Union or if you're going to the United States. They just play it safe, put the message out there for everybody. So in the European Union, they must have the consent. You can avoid keeping persistent cookies. The Google Chrome incognito mode or the Microsoft Edge in private mode or the Safari private browsing mode, all of these do not save information about where you've been. They don't save the temporary information. When you go out to a website, it stores the web page that you've been to in its local disk. It erases all that. It erases the cookies, the history, so it doesn't require you to go. So if you want to go out and don't want anybody to know what you've been looking at, you can use the incognito mode. A place where I work, actually when I grade advanced placement exams, the IT people of the ETS, Educational Testing Service, tells us to always use incognito mode. So when you first log in, it doesn't have any old cookies to confuse the system. So they always want us to use incognito mode. If you are using JavaScript in an HTML page, you can access the cookie by the document.cookie node. That is the name of the node in the domain object model that accesses cookies. If you look at that, you can see the cookie. Unless it's an HTTP only cookie. An HTTP only cookie cannot be accessed by JavaScript or HTTP. Let me quickly mention the domain object model that is used by JavaScript and HTML. Basically, it's a hierarchy of objects that appear in the web page. Every paragraph, every button, every input field, every picture, everything, actually, every object appears in the web page is part of the hierarchy, and you can access it through JavaScript. And not once you have the object, there's all sorts of parts of that object. The interesting one, inner HTML is the text. You can change the text that appears on that. Node name, value, lots of stuff you can access. Attributes is interesting. Now, usually you can find the object by using a get element by something. Get element by ID returns the element that has ID. When you create a object in HTML, here's a paragraph, the bracket P, it's a paragraph ending in the /P. You can give it an ID, and you can put an ID on, I think, every object out there. And then in some JavaScript, you can say, I want the element that has the ID that matches the ID here, in case the 1. And it returns a object, which in this case I called my paragraph a variable in JavaScript that contains the object that will be this paragraph. And then by changing the inner HTML, instead of saying original message, it will now say on that location on the screen something completely new. So you can change the text of the web page. You can change styles, all the style parts. You might have a cascading style sheet that decides that this piece of the text should be this color, it should be that font, it should be italics, bold, whatever you're interested in. You can change those style things. Here's an example. Again, we have ID 1. We do a get element by ID on document, document being the root of the whole thing. And then you can change the color. So here we have a button. And when you click on the button, on click is an action that JavaScript will take when you click on this object. And it says, get me the object that has that style, and then set the style and color to red. Button becomes red. You can change other fields, attribute names. Particularly, it's interesting for pictures. You can change the picture that appears on the page. So if you have a picture, then it's going out again. In this every case, I'm using the ID because this is simple. The ID typically returns one object, unless you got foolish and put multiple objects with the same ID, which can you? I think well, it would be foolish to do so. Then you lose the ability to go out. Somebody said you can't do it, which might be true. I guess I haven't been that stupid to try, but but you might anyway. It would defeat the point. ID is used to identify a particular object. It's the simplest way to identify a particular object. You can, of course, go out and say, give me all the paragraphs, give me all the image objects, and then go through a list or array of the image objects to find the one that you're interested in. Easier way, of course, is just go to a particular one, unless you want to see all of them. If you wanted to go through all the images and change every image on the page, I suppose you could write JavaScript to do that. But here we're just changing the one.src. We're changing the source parameter to a different file. So when you do that, the system will go out and get the happy JPEG file and display it on the screen. I know that not everybody out there is a programmer. Not everybody has used JavaScript or HTML. A little bit is necessary for the assignment, very little. I'm asking for alert messages. Alert message, nothing special about an alert message, except it's a harmless message. If I pop up an alert, you haven't hurt your system. I'm trying to do this as opposed to doing nastier things that can be done. JavaScript is very flexible. You can do many things in JavaScript. And some of them, of course, are hazardous to your system, which is the way users attack your system. So we're using alert. In fact, the assignment that's due next week has 2 alerts. You have to do an alert message. There's alert parentheses, and then the text of a message. Right parentheses and a semicolon. This should be, of course, if you're doing this as an attack, you'll probably want to go bracket, script, bracket, then the alert, and end it with bracket / script, bracket. So put this inside script, but there it is. I think I told you the answer now. It displays that, displays a pop-up message. In JavaScript, the plus character is used for concatenation that puts 2 strings together. So user was a variable name in JavaScript that contained the user's name. You want to say, hi, user, you can concatenate hi blank with the user's name using a plus. I might point out that frequently people write web applications using JavaScript on the browser and PHP on the server. That's very common. PHP uses the period for concatenation. JavaScript uses the plus. And I can't tell you how many times I've put them in the wrong place. Somebody should have been thinking when they did that. Okay, yes, JavaScript, again, you can activate it in many ways. You can call JavaScript functions on certain events. There's all sorts of events. Some of the more interesting ones are a mouse click. If you click an object, you say, oh, when this object is clicked, do this. You can say when the mouse moves over this. Frequently you see when your mouse moves over something pops up. Yes, you can do that. When you enter a page, when you leave a page, sometimes leaving pages, do you really want to leave? Yes, I want to get out of here, go away. So you can see that. And of course, when something is changed. So there's all sorts of things. We start, unload is one of them. There's all sorts of events that a Java function can be triggered by. So that brings us up to another question here. Let's try this one. Maybe. Okay, try again. All right, hopefully the online people can see that question. And I'm pretty sure that the people here can see the question. Online people, do you see the page is almost all white with the question in it?
I see the question and all the options to choose.
Yeah, but nothing else. You don't see the next slide or something like that?
No.
Okay, good. Sorry. All right. All right. Okay, 2/3 of the people online have already answered the question. All right, we got. Okay, let's get your cards up, please. And studio audience. You gonna vote today, or just keeping? Oh, I'll get your card. Okay. Oh well. Let's see. That's and it will share the result. Well, I didn't fool. I did not fool too many people. There's a common myth that you cannot be attacked if you don't click on anything. No, that's not true, because you can have a JavaScript function embedded in the page. Of course, you never see this because the browser just shows it unless you go out and look at the source code of the HTML where you see this. That can happen on load whenever you enter a page. So as soon as you're looking at the page, the JavaScript starts executing. So the answer would be B. Now, sanitizing all input is a reasonable question. You might think, well, if I sanitize the input, but no, this can be before anything asks for input. This can be as the page is loaded. So the answer is B. All right. The title of today's lecture was SQL Injection. Now we're finally getting around to it. About time, huh? Okay, SQL. Real briefly, SQL, structured query language. It's a declarative language for managing databases, relational databases. Declarative language, says the old professor who taught programming languages far too long, is a language that doesn't tell you how to do it. It tells you what you tell the program, what you want done. In other words, if you're writing Java or C++ or Python, you tell the computer how to solve the problem. If you are using SQL, you just tell it what you want it to do, and it figures out how to do that. It's been around. It has a bunch of theory. It's been there for a long time. Theory, I know people don't like the computer science theory is not everybody's favorite topic, but it's important because there's a lot of information in the theory. We know that this will work because there's theoretical mathematical basis for it. When we write programs, most of the time we're just flying by the seat of our pants. They just write a program. I think that'll work. It looks like it might work to me. How do you know it will work? You can't. It's very hard often to prove this will work. They can prove that SQL works. Developed back in 1970. I remember late 70s, early 80s. Our boss had us all watch a video by Mr. Codd himself talking about relational databases and SQL because they were thinking of changing their old database to an SQL or a SQL relational database. That was way back. Codicil databases. You can look that up. I don't know about Codicil. C-O-D-A. Yeah, I'm not sure. It's Codicil. By the way, I might point out that SQL works very well with SQL servers. In fact, the SQL database that I am using for the assignment is not on the website. It's someplace else out in the ether, and it goes out and accesses it. Now, the whole idea of SQL is you got tables with fixed columns. You have, here in my example, these are the column names, and then you have a bunch of data. You have a bunch of rows, sometimes referred to as tuples, that contain the data and the fixed set. It's very formatted. And then we can access that table. Okay. It's SQL injection is a serious attack. Look out there, one of the worst credit card thefts ever was done through SQL injection. It was quite a while ago, 2008, so that's 14 years ago. Nevertheless, they have the honor of being the biggest credit card theft. So Google it. All right, let me quickly go over SQL so everybody has an idea how it works, so you can have an idea how to attack it. SQL, it's real simple. I'm not going to tell you all about it. We have courses on databases that'll tell you all you want to know about SQL and more. Basically, select is the most common statement. Select is used for what they call database queries. It says, give me information. Go out to the database and retrieve the information that matches this. So here I can say, I want these columns. Those, of course, would be the names of the columns here and whatever you want to call them. Those columns from table name, the table. Right? The star says, just give me everything that you have from that table. Give me all the column information. And you can also specify a where, saying, I don't want everything. I want particular rows that meet certain criteria. Now, you can also insert data, put new values into the table. Here, this first format, just insert into the table values. Now, here they are in order. You don't have to specify what columns. So the first value goes into the first column. The second value goes into the second column. And this will create a new row in the table. What is I've seen more often done to be a little more specific. You can say the column name equals the value. So in the example I had, you can say ID equals this, last name equals this, and so forth. You can also, of course, update the rows. Updates are typically done with a condition, otherwise you'll update the whole table, but you can say, update this table, set this particular column to this value where this statement is true. We'll see some examples of that. We'll see conditions later on. You can delete rows, you can delete the whole table. Conditions, yes, like I said, the conditions is typically where a column in select state. Well, okay. Normally what I see is where column equals this. Yeah, you can do it all sorts of ways. Okay. And there's many functions. Count, which you'll see in some of my examples. Count simply tells you not what the data was, but how many rows had that value. If you want to search and see, give me all the rows that have the name equals Williams, it'll return the rows. Or if you don't care what the value is, you want to see how many were there, you can use count and return count to them. You can get really fancy. You can do pattern matching. You can go where not just equals, but where the value equals, something like this, matches a pattern. Some of the most common SQL databases is MySQL or Oracle. Oracle has a commercial SQL database. Also turns out that Oracle manages MySQL, which is a free database. Somewhat concerned when the most popular free database is managed by the company that sells the most popular paid-for database. But on the other hand, you can say, well, they ought to know how it works. Okay, so let's show some examples here. Say we want to get somebody's name. We want to get information about a user. So this is PHP. I have several examples in PHP, and I know a lot of you don't know PHP, but we're just looking at this to get the database concept. So in PHP, all variable names start with a $sign. So I want this first thing says, get the variable that was sent from the website. So when you go to the website, you fill out a text field that's labeled as name within the program, then it sends it back to the server, name equals the data you sent. So this is going to get whatever you entered into the name field. And it puts a variable called $name. And then it generates a query. So we generate a text string that goes, select star, select everything from restaurants where name equals, and then it puts it in there. The quotes, we have a single quote, a double quote. PHP can use either single quotes or double quotes to create a text string. If you start with double quotes, you can easily embed single quotes into the string. And if you start with a single quote, you can easily embed double quotes in a string. But you have to start using escape characters if you want to mix it up. So here at the end, you see this is a short string with only one character in it, which is a quote. Okay, so we have the select star. And then we submit that query to the query system, and it returns the result. But this is the MySQL. Query is a function from MySQL that does that database query on your database. Here's a more elaborate example. So we're going to log in. This is the classical login stuff. We get the name and we get the password from the information that comes from the website form. So now we have the name and password. And we set the query. So here we have the query, and we embed the name and password. These should not be green. My crayons weren't working correctly. They should be blue, I guess. $name is a variable, and password. We're going to put that in, so concatenate everything together in a string and make the string. So, and then we take that string and we run it through the query system. We get a result, and typically say, well, did we get anything back? Because if there is no user with that username and that password, the database query will return nothing, a null string. So the number of rows greater than 0 means, yes, you got something back. So imagine I put my name, my user ID, and my password here. It would create a query to the database, select everything from login, where the username is Ken W and the password is secret. It goes out, submits that query. And if in fact there is a row in the database, the username field being Ken W and the password being secret, then it will return everything about that row. If there are no rows, it returns nothing, and it returns nothing, there'll be no rows. This will be equal to 0, so this will be false and it won't allow. Now, SQL injection. Here's the attack. What if the user does not nicely enter just their name? What if they start entering some SQL statements in there? Let's take a look at this. We have a real simple count login where the name equals this and the password equals that. Well, these are variables in the PHP. But the password you put, instead of putting a password, you put X single quote space or space quote A quote equals quote A, and then that's it, no quote in the end. And then you put it in here. So now it's going to take the username, say the username with Alice, which it takes from the variable. And then since the password equals quote X or quote A equals quote A. Well, A equals A is always true. Lowercase a always equals a lowercase a. So that's always true. And we have an or here. And remember your Boolean logic. Anything ORed with true is always true. So the where statement is always true. This will match everything. So you fooled the login system by giving it not a real password, but by giving it something that, when concatenated into this, creates a SQL query that is always true and will always return, in this case, many rows. Doesn't the user ID doesn't have to match, X does not have to be the password, because the or true is going to work. Here's another example. I got plenty of them. Same thing. In this case, though, we're going to enter just X and then insert into login. Assuming login, of course, is the table, set username me, password. So we're creating a new one. So then when they execute it, it comes here, it goes out to look for a username, which it may or may not find. It doesn't matter, because it's also going to create another row in the database. It's going to insert both the username me and the password my secret. So maybe my first login isn't going to work, but my next try will be with the username of me and the password of my secret. And now I can log in. Then you can, here's another one, getting even nastier. So this case, here is what you've entered. You enter X. The quote is important because we have to it's going to embed this with a quote here. And so you have to finish that quote. Actually, that quote there should be a black quote, but yes. So it finishes that quote here, and then semicolon, and update, login, set password, or user ID is admin. So if there's a user ID out there called admin, then it's going to change the password. So now you know the administrator password, and the administrator does not. That's a pretty nasty situation for the administrator. I might point out that SQL statements, like many other programming languages, end in a semicolon. So you should put a semicolon at the end. Some SQL systems are more forgiving if you forget the semicolon, others are not. Putting the semicolon in always works. Also, you can put a comment in SQL statements by putting 2 dashes, minus, minus. And minus, minus means everything to the end of this statement is a comment. It's like putting slash, slash in a Java or C++ program. Or Python, just everything else is a comment. That's valuable because sometimes you don't know exactly what the format of the statement is. Is it going to ask user, password, or password user? It doesn't matter. If you enter the username, so the username that you entered is whatever, quote, or 1 = 1, semicolon, dash, dash, then it creates the query that select star from my table where user ID equals whatever, or 1 = 1. Well, 1 = 1 is always true. The or means it always matches. And then the semicolon, dash, dash means the rest of that query that was originally there is now just a comment and will be ignored by the SQL system. So it doesn't matter what they put in there, whether it was select password or user ID. Before our other examples, we were kind of counting on the password being the second thing. Here, it doesn't matter. We're going to get them. So I would recommend putting semicolon, dash, dash on the end of your queries. It makes it work more reliably. Now, this is not really a weakness in SQL. It's a weakness in the user programs where they are taking user data and putting it into executable code. That is always a danger. And also, I might point out that PHP and stuff has access to other functions of the system. And if you can access into it, you can do almost anything on your server. Now, I have a question here. So let's launch yet another poll. Find the button. Oh, okay, online people should see the question. Let's see how good our instructors are. So this no right or wrong answer. Well, there is. Yes. Oh, keep your fingers off. Okay, it doesn't. Yeah, the clickers are pretty. Oh, well, you just changed your mind there. Okay, got him. Oh, all right. We're kind of matched between yeses and nos, and a bunch of people who never took database class. I understand, particularly the certificate students may never have taken a database class. I hope all the undergraduates have. It was required in our undergraduate program. Most graduate students, but not all graduate students have. But it says that the instructors did not slightly more. Oh, I'm sorry. Let me show the results to the online people. Slightly more people said no than yes. So we still have database teachers teaching insecure ways. I think I have to talk to the database teachers. I talked to people who used to teach database who no longer do it. They weren't moved. For a department for whom cybersecurity is one of its major focuses, we don't always teach students secure techniques. That kind of annoys me. All right. So get rid of this and moving on. Okay. We've talked previously about keeping passwords. If you're storing a password in a file, do not store the text of the password. Instead, store a one-way hash of the password, whatever your favorite one-way hash is, SHA-256, SHA-1. SHA-1 may be not totally secure, but it's darn secure. Nobody has a really good way to undo it, so you can hash the password text and save the hash. And then when your program gets a password, you hash it and then look for a database entry with that particular hash code. So you can match the hashes. Also, it's not a good idea in your program to blindly say, well, if I got anything back, it must be okay. No, you could say, get the password. In other words, you could say, select password where user ID equals what they gave you. If you didn't get anything back, then give an error message. If you got something back, then check to see if that password, which hopefully should be the hash value, matches the hash value you got and compare it. That's much more secure. We'll talk about other secure methods in just a bit. Might also point out that the database application may run with more elevated privileges. And this is, again, another place where you have to make sure that you don't give the user ID, the task that runs the database, or the user that runs it. When you use a database, when you write a program that accesses the database, there is a first statement you have to execute that says, I want to connect to this database. You indicate which database by giving the name of the database and the user ID and password that you're going to execute this. The user ID and password should be given only enough privileges to do the task that that database needs. If this program is only going to read the file, then it should only have read-only access to the database. If you don't give it write access to the tables, then it can't change it. Also, of course, only give it access to the tables it needs. So if the task is going to log in, if this is the login function, and it's going to just read the database, then only give it read. If it's possibly going to be able to create new users, if you click on the create account button, then that account should be able to read and write the login database, but no other tables. SQL has many commands that create user IDs and limit the access that that user may have. So make sure that you limit the user only to the abilities that we need. Again, it's the principle of least privilege that we talked about before. Other nasty things you can do with SQL injection. Maybe you don't know too much about that database. The examples I gave, I knew exactly how the tables were named and what the name was, but you can figure those out. You can often guess commas. If you want to know the email address, what are you going to call it? Or if you want to know the username, well, what are you going to call it? User, username, login name. There's probably no more than a dozen possible names you can pick. So in this example, what do you want to know of emails? Email / address, email ADDR, guess. And then you can put in queries by changing the input fields. There's the SQL injection attack. If it doesn't work, you'll get back an error, possibly a server 500 error, or it doesn't work. But if you hit it, you'll get back a different kind of message. Might still be different, but you'll get a different error message if you hit it. So you go, I now know what the name of that field is. And you can guess. You can guess a lot. You want to guess the tables. Now you know the name of the field. If you you reference table period field names, how you reference. Now you start putting the table names out there and keep guessing until you got it. And unfortunately, in order to make programs realistic, everybody uses field names and table and column names that make sense to a human being. And of course, that greatly restricts the column names that you have to guess. You could get tricky and put column names and put a bunch of random characters afterwards that make it impossible to guess. So again, you can start guessing that. Did they hit it? one of the ways to fix this is to sanitize the input. Make sure the input doesn't contain characters that will bunch of. Don't let them put quotes in there, because quotes, the single quote character, that means that you run into O. Henry or O'Brien, that they can't put the quotes in there. Just going to have to do without it. So check that. It's much, much better to check that allowable characters are used instead of doing the inverse and saying that they use unallowable characters. Particularly if it happens to be Unicode, there are zillions of characters. Unicode has got 65,000 possible characters, and there's only a couple dozen of good characters, maybe 60 some, 70 some good characters that you can use. So check against the good ones, which is normally used as a whitelist as opposed to what they call a blacklist, that you can't, characters that you can't use. And then again, it may be tricky if we want to allow O. Henry in there, but not. Also, sometimes they'll escape it. Remember, the %27 is an escape for the quote character. Put that in there, and somewhere along the way, it'll probably decode that back to a quote. And of course, international sites, if they're doing this in Arabic or Chinese or katakana or whatever you want, it may be really tough to check them all. Also, sometimes they can do this without any special characters, particularly for numerical values. If they are checking for numerical values, you can, or where a number equals something, where a count or a quantity value, it's going to be a numerical, so you can just put the number equal, and then 1 equals 1, of course, is always true, so this will always work. But you should scan these things. The best way to do this is never concatenate user data to make an executable SQL statement. Don't do it. There are other ways to execute SQL statements that are better, they're faster, much more secure. Here's how it works. Okay, we open the SQL, of course, in here, it's putting the table name, site, user ID, password, open it up, it gives you an SQL object, whatever an SQL object is. This is PHP again. Then we create a query, but this time we put quotes, or excuse me, those are question marks. Put question marks where we expect to put data. And then we prepare the statement. On the SQL object that we create up here, we call the prepare function, passing it this data. And that creates a SQL statement that has been prepared. And then you can do the bind. Bind says, I have two strings. Well, there's two question marks in here. Both of them are S's, string. And I want to put group ID into the first one and player into the second one. And then I'm going to execute it and get the result. The advantage of this, it looks like, well, what if you put in escape characters here, quotes and everything? No, because it's going to treat the data values as data values. No matter what you put in there, it's going to take that as a data value and then search for that. So if you put, X quote space OR, blah, 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 then it's going to look for a username that's X quote space OR. It's probably not going to find that. Whatever it is, it's not going to execute whatever user data you put in there. It's going to use that data as data in the query. So that's parameterized SQL statements. They're not any more difficult to use. They, in fact, are much faster if you're going to execute that query multiple times. I might point out, every time you call a function, functions can return an error status. I didn't check for that. You should always check for error statuses so you know if your program is working or not working. If you don't check for error status, things could be blowing off and you never know. So I took out all that to make the example short. So, summary, never, ever concatenate user data into a string that you will execute. Either as a database or as any other type of command. Cross-site scripting, SQL injection are all created by taking user data and putting them in an environment where they will then be executed by the system. That's just looking for trouble. Sure, you can try to clean all the user data, but if you just don't do it, you don't have the problem. I might point out there are certain system things that will keep you. MySQL, one of the more popular, well, it's popular because it's free. Free is always a real draw to most people. I like the idea. Doesn't allow multiple statements. So you can't put statement, semicolon, another statement. You can't put statement. But other database systems will allow that. On the homework, assume I'm using something other than MySQL, because you're going to want to put multiple statements together. So we'll assume we're not using MySQL, that you can put a semicolon and put another statement. Again, least privilege. Give the account that's running this the least amount of privileges. Don't run it as root. It should be a non-admin user. It should be a simple user that just has the privileges to do what it needs to do. Also, in some systems, Apache, if you get an error, it will print all sorts of error messages, which is really nice if you are debugging it. But if you're not debugging it, don't tell the attacker all the information about what file and everything else you're using. Limit that. Also, limit the lengths of the input. If you're expecting the user to enter a user ID, which can be no more than 6 characters, don't let them enter more than 6 characters. Most of these attacks take more characters. You know, it's character quote space OR space quote. No, it's longer. So if you limit the input, it makes it more difficult to enter a SQL injection attack. So one more question here. Find it. There it is online, and the people here in class can see it. All right, let's do a shot here. Oh, you gotta put your card up. Oh, there, oh, no. Are you not voting today? Okay, the vote is in. All right. Oh, B is really popular. That's good because of all the answers, B is the best one. Yes, the online people figured that out. Non-SQL databases. Non-SQL databases have similar problems also. I always figured students use non-SQL databases because they never really got through the database class and understood SQL very well. There are non-SQL databases. They work something like search engines like Google. Google doesn't use an SQL database because it's looking at the text of documents. Non-SQL databases are very good if you want to search the text of a document for values. When you have information that's not tabular. But if you have tabular information, that's the time to use a relational database in SQL. A lot of systems, a lot of students just say, I'm going to use a non-SQL database, even though they haven't the foggiest idea what they're doing. And my mouse is stuck. Oh, got rid of it. Okay. Blind SQL. Blind SQL is for doing SQL injection where you know almost nothing about the attack. We talked a little bit about being able to find field names, find table names. That's blind SQL. It's a little slower. It's obviously much faster if you know this information, but you can, through trial and error, find this out. And in case you get bored, don't worry. There are tools to help you do this. Of course there are. You go out and make attack tools. You can go out and find letter at a time of a field by using a pattern match. So you can find pattern match. You can look for characters at a time. So if there's 8 characters in a name, you can do it through a binary search. Or yes, binary search. Log-based to that. You can get through in 7 requests. There's 8 characters. It's 56 requests. Takes 6 requests to find out that the thing is 8 characters long. We're not going to go into the details of how this is done, but yes, that seemed to be beyond purpose of this course. So 62 requests, and just do a little arithmetic. If it takes 10 seconds to make each request, you're doing it by hand or your program, of course, will do it much faster than that. And if there are any mistakes, you can figure it out in 62 times 10, 620. It's a little bit, that's 10 minutes and 20 seconds. So it doesn't take too long. If you're using a tool, they could probably do it in just a few seconds. And then, okay, now that we found out the name of the fields, we can go on and find out, whole information about the database with a little bit more effort. That's it for today. Reminder, there is an assignment out there. It's for both graduates and undergraduates. It is based on SQL injection and some cross-site scripting. There are 4 questions detailed in the assignment, which is out on Blackboard under quizzes, tests, and exams down at the bottom. All of them require you to go out to this website. Ooh, let's see, can I click on this now? No. Okay, we'll go to that in a minute and show it to you. Let's do by noon, not midnight, by noon next week on Tuesday. I want to have enough time so the TA and I can grade it. There is the exam. We are here, just talking about SQL injection, denial of service, which is, by the way, chapter 7 of the textbook, and review. Also, sometime between now and Monday, hopefully sooner rather than later, but depends on how quickly I can write a practice exam. What material? Well, we're going to cover everything we covered since the first exam. There'll be no questions relying particularly on material from before the first exam, second exam. And then I'll give that back on Monday. This little red bar here indicates that that's the last day to drop a class without a grade evaluation. So if you get it back and you go, oh, I'm not making it in this course, only a couple of students are in trouble, then it might be time to bail out. Most importantly, if you're a graduate student, you never want to get an F because an F destroys you. You're out of the graduate program. And then computer forensics in 2 weeks. And a reminder, of course, please register and vote. Now, where is it? Vote and the choice is yours. Don't vote and the choice is theirs. If you're going to register, you need to register this week by Friday at 5. That's the end of the day's work. Now, you can also register at early voting. But if you need to change something, particularly if you're registered some other community, you need to move your registration here to Greensboro, then you need to do it by Friday. Also, election day is Tuesday, November 8th. You cannot register on election day. You can register early voting, but you cannot register on election day. And that's a Tuesday, I think the Monday before that, or sometime close before that, we will be talking about voter security. All right, that's it for today. So see you next week. Make sure you do the assignment. You might want to take a close look at that. Oh, can I have my cards back? Close look at that cartoon.
See, they didn't use parameterization.
You're right, they didn't. Hope to sanitize your database inputs.